Welcome to our new video. Today we are going to talk about renewable energies harvested from the kinetic energy of waves and water currents. Don't forget to subscribe to my channel for more videos like this one. Because the movement of waves is driven by the consistent forces of wind and tides, wave energy is thought to be more predictable than other forms of renewable energy such as solar and wind power. This means that, in contrast to the intermittent nature of solar and wind power, wave energy can be more easily forecasted and planned for. Another reason is that certain geographic areas have more consistent and reliable wave energy resources. Coastal regions with strong prevailing winds or large tidal ranges, for example, have higher wave energy potential. This means that wave energy projects can be located in areas where the resource is known to be abundant and consistent, making the amount of energy generated easier to predict. Wave energy can also be concentrated, reducing uncertainties and increasing power output predictability. Other forms of renewable energy, such as solar and wind, may have high variability in the short term, depending on weather patterns. It should be noted that wave energy is still a relatively new technology, and forecast models are constantly being improved to improve their accuracy. Furthermore, wave energy, like any other form of energy production, has its own set of uncertainty and variability, and the energy generated can vary depending on the location, depth, and weather conditions of the site. The water of the oceans of the world is almost always in motion. Hardly ever interrupted waves break at the coastlines. Sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Voigt Hydro Wave Gen is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases. The operating principle of this wave power station is as simple as it is ingenious and includes chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station day and night, all year round, as long as there are waves. The world's first power station of this kind was put in service as early as November 2000 on the Scottish island of Isla and has been feeding power to the grid ever since. Voigt Hydro Wave Gen is convinced of the commercial potential of wave energy. We are certain that our wave power stations can make a significant contribution to supplying the world with climate-friendly energy. A marine turbine generates electricity using the force of Seal River currents, a free and abundant renewable energy source using a barge. The marine turbine fixed to a metal structure is submerged, then placed on the seabed. The marine turbine comprises a fixed part, the stator, and a moving part, the rotor on which blades are fixed. The force of the water makes the blades start to move, causing the rotor to rotate. The interaction between the electromagnets of the rotor and the copper wire coils of the stator then generates an electric current. The current generated in this way is converted into direct current by a converter and is transmitted through an underwater cable to the land, converted back into alternating current. It is then boosted to 20,000 volts in order to be delivered to the electricity distribution network. Regular maintenance and inspection ensure that the marine turbines remain fully operational. Marine power production does not generate greenhouse gases. Reliable and predictable. It can be used continuously to meet electricity needs on any day of the year. These are just two methods for harvesting energy from the sea. There are dozens more. Because of its predictability, round-the-clock availability, lack of reliance on energy storage, and non-polluting nature, this type of renewable energy has enormous potential. Scientists and engineers are working hard to reduce the cost and efficiency of this renewable energy source. Thank you for watching the video. Until next time.